Welcome to our class. In this question, we are going to be looking at bearing solution. It says x is a point due east of point y. So we are going to locate y. And at every point, this is point y. At every point, you have 4 cardinal points: the east, the west, the north, and the south. Okay, so x is a point due east of y, and this point is y. If you go due east, this is east, you will see x that has its own cardinal points. So this place is x that is due east of y, but y is due west of x. Okay, z is another point on the same coast, but 6√3 kilometers due south of y. Come to the same y, you locate z, but due south. This is south. Then you see point z here, due south of y. But the distance is 6√3 kilometers. If the distance xz is 12 kilometers, this is x, this is z. So we are going to join a straight line from x to z. Okay? From x to z, the distance xz is 12 kilometers. This is 6√3 kilometers, this one is 12 kilometers. The question said we should calculate the bearing of z from x. The bearing of this place, bearing is from a particular point. What angle are we going to turn from north of that point? At what angle will you turn clockwise to locate a straight line that will lead you to another point? So if we are going to z and we have x, because we're looking for the bearing of z from x, so from x, we have x and we want to go to z. From the north of x, what angle are we going to rotate to locate a line that will lead us to z? It is from north, we will rotate 90, 180, then this other angle, before we can now move a straight line to z. So from here to here is 180. So all we need to get is just this small angle, which I can call alpha. Okay, but you can see that this angle is outside this triangle. Whenever you're solving bearing, it's always the enclosed shape that you can use to get whatever thing you are getting. So why not we get this other angle that is inside the triangle? Let's call it theta, because we know that theta plus alpha is 90 degrees from what we can see. This is south, this is west, and that forms 90 degrees. Okay, so if we can get alpha, we subtract it from 90. If we can get theta, we subtract it from 90, then we have alpha. So from this triangle, you know this is a right angle triangle, and if this is theta, this is the opposite, and this is the hypotenuse. And we know that opposite of hypotenuse is equal to sine theta according to our trig ratio. Okay, if the opposite is 6√3 and hypotenuse is 12, it is equal to sine theta. 6 here, we divide 12 to give us 2. So we are going to have √3/2 is equal to sine theta. And we know from our trig ratio, if you know the trig ratio table, that sine theta, sine 60 will give you √3/2. Okay, this is equal to sine 60 to give you √3/2. It therefore means that theta is equal to 60 degrees, because it is only sine 60 that will give you √3/2. There's no other sine angle that will give you that in first quadrant, because this is a right angle triangle, and there is no angle in this triangle that is beyond the first quadrant. Okay, so we have gotten our theta as 60. It therefore means that if theta is 60, if we substitute 60 as theta here, alpha will be equal to 90 minus 60, and that is equal to 30 degrees. But that is not what we're looking for. We're not looking for alpha, we're looking for the bearing of z from x, and that we have gotten 90, 180 plus alpha. So the bearing of z from x is going to be 180 plus 30, 180 plus 30, because alpha is 30, and that is 210 degrees. So the bearing of z from x is 210 degrees. That is the answer to this question. See you in our next class.